This is class 27 of my arithmetic course. Today we're going to learn rounding. If you haven't done the homework from class 26, do that homework before watching this video. We'll start out with an example to show the principle of rounding. Let's say that the price of gold is $1,325.48. It turns out at this time in history, that's about what the price of gold is, apparently. But if you're going to go around telling people the price of gold, and by the way, that's for 1 ounce. If you're going to tell people the price of gold, you're probably not going to say these numbers. You're probably just going to say $1,300 for 1 ounce, or you can say $1,300. $1,300 is the same thing as 1,300. And the reason that you're going to do that, there's a couple reasons. One reason is it's just easier to say 1,300 rather than 1,325 and 48 cents. The second reason is that these numbers are not really that important because the price of gold goes up and down. So it's possible that these highlighted numbers are actually going to change. So they're just not that important. So what we do is we take this number and we round it to this number. That's the principle of rounding. When you don't need an exact number, you round the number to something that's easier to think about. Another example of rounding is when you have two numbers that you're going to perform an operation on, and this operation is addition, but you don't want to do the full calculation because it might take a while to add those numbers. So what you do is you round this number up to 700 because 698.02 is really close to 700, so you just make it 700. And this number is fairly close to 200, so you just round it to 200. So instead of 698.02 plus 211.55001, you just round those two numbers to 700 and 200, and you add them up to get approximately 900. Now, if you actually add those numbers, the actual number would be 909.57001, which is pretty close to 900. As you can see. So we didn't really need the exact answer, so we chose to just round those numbers to kind of estimate the answer. That's called estimation. So these are just two quick examples of why rounding numbers is useful. There are many more reasons, but we don't really need to go through all of them. All right, so to learn how to round, we have to review the place names. So we've already done this, but I've color-coded them now. So remember, here's your decimal. The number to the left of the decimal is in the ones place. And if you go to the next number, you just take the place here, which is the ones place, and you multiply it by 10. 1 times 10 is 10. Now you're in the tens place. Then you take the number in the tens place, or not the actual number, but just the place name, 10, and you multiply it by 10 again, and you get 100. And you take 100 and you multiply it by 10, and you get 1,000. That's this place. And you multiply 1,000 by 10, and you get 10,000. That's this place. So the place names you can remember just by starting at the number directly to the left of the decimal and just multiplying by 10. 1 times 10 is 10, 10 times 10 is 100. 100 times 10 is 1,000, 1,000 times 10 is 10,000, so on and so forth. So again, we have the ones place, the tens place, the hundreds place, the thousands place, and the 10,000s place. All those names have S's at the end. So the number directly to the right of the decimal, all those numbers, instead of putting an S, you put a THS. So they're all the THS sound. And the number directly to the right of the decimal, you don't start with 1, you start with 10. But instead of 10, it would be tenths. and then multiply 10 by 10, you get a hundredths, and then multiply 100 by 10 and you get a thousandths. So that's how you can remember the names of the places, just by starting on one number, and then you go to the next number, you multiply by 10 to get the next number, and then multiply by 10 again to get the next number, so on and so forth. So I would suggest that you go on the internet before we continue with this class and search place value names, and then find some sort of a chart, because I'm not going to keep this chart so you can see it in the entire class, because you're going to have to know the names of those places. All right, so that said, let's get into our problems. We're going to round the following numbers to the nearest value indicated. So we'll start with number 1. This column says to round to the nearest thousands, or excuse me, the nearest thousand. So we have to find the thousandths place. So the thousandths place is here. And again, you can confirm that by looking at a chart. If you don't remember the place values, just go and search Google Images and find a place value chart. That's the thousandths place. And we're going to round to the nearest thousand. So you have not learned this yet. You have not learned what we're about to do at all. So you got to pay attention here. Here's how you round. We're either going to round up or we're going to round down. So we need to figure out whether or not to round up or down. So in order to figure this out, we look to the number directly to the right of the number in the thousandths place. So again, the blue highlight is the number in the thousandths place. That's 1. We look to the number directly to the right, which is 9. And the 9 tells us whether or not to round up or down. So if the yellow highlighted number is 5 or above, we round up. If it's 4 or below, we round down. So I know what you're thinking. You're thinking, well, what does that mean? What do you mean we round up? Well, obviously we're going to round up because the yellow highlighted number is 9. So we're going to round up. So here's what we mean by rounding up. The number in the blue is going to go up by 1 because 9 is 5 or bigger. So we're going to round the blue number up 1. We're going to write an approximately equal sign. Remember the approximately equal signs? That means it's not exactly equal to, but it's approximately equal to. And so we're going to round the blue number. We're going to make the blue number go up 1. And then all the other numbers are going to go to 0. It's that simple. Rectangle your answers. All right, so we're going to do the same thing for number 2. So if you didn't understand that, that's okay. We're going to do a lot of these problems. Don't worry about it. But now we're going to round to the nearest 10. So we have to find the tens place. That's right here. And we have to know whether or not we're going to round up or down. So you look to the number to the right, and we ask, is this number to the right, the number in yellow, is that number 5 or greater, or is it 4 or below? Well, obviously, it's a number that's in the category of 4 or below. So that means we're going to round down. In the previous problem, number 1, we rounded up. In this problem, we're going to round down. So approximately equal to. Because we round down, now we haven't rounded down yet, so I need to teach you how to round down. I taught you how to round up here, and we're going to do that many more times. So don't worry if you didn't understand it. But here we're going to round down. So when you round down, you keep the blue number the way it is. It's just going to stay 5. And just like all the numbers here went to 0, all the numbers in this problem are going to go to 0 also. Except the number in blue. The number in blue is always going to either stay the same in this case, or it's going to go up in this case. So those numbers, they always go to 0. The yellow numbers and all the numbers to the right of the yellow, they always go to 0. So we rounded up here from 31,946 to 32,000, and we rounded down here from 52 to 50. Now again, if you didn't understand any of that, that's okay. We're going to do a lot more problems before you actually try some on your own. Now this is going to be another problem we're going to round up. So we have to figure out what place we're going to round to. So it says to the nearest 100. This is the hundredths place. And again, if you're having trouble figuring out which places are where, then that's not a big deal. Just go on, like I said, go on online and search the place value chart. I could show you it here, but then I wouldn't be able to zoom in on what we're doing. So that's the hundredths place. Look to the number directly to the right, and as you can see, that number is 5, or it's in the category of 5 or above, so that means we round up. So the 2 goes up to 3, and all the other numbers go to 0. Big deal, right? This stuff is easy. All right, let's try number 4. It says round to the nearest 1,000. So we find the 1,000 place, which is here. Then we look to the number to the right, and as you can see, 0 falls in the category of 4 or below, so that means we round down. So this number is approximately equal to 980,080. So again, this number told us to round down, which means this number doesn't change, and all these numbers, as usual, they all become 0. It doesn't matter if you're rounding up or down. All these numbers, the yellow number and all the numbers to the right, they'll always go to 0. So you're kind of getting the hang of it now. And if you're not, that's okay. We'll do more problems here before you start some on your own. Now we're going to round to the nearest 10, because it says nearest 10 up here. And we have to find the tens place. This is the tens place. We look to the number to the right, and 6 tells us to round up. So we make the 7. Let me write the other numbers first. We make the 7 go up, the blue number go up to 8, and the other numbers, the yellow numbers and all the numbers to the right, they go to 0. Whoops, I forgot to rectangle that one. And I forgot to rectangle this one. Don't forget to rectangle your answers. No excuses. You got to number your problems. You got to circle the numbers. You got to write your equal signs if you have to. You got to rectangle your answers. You got to do all these things. No excuses. All right, number 6. I think we'll try one more, and then you can try some on your own. So it says round to the nearest 100. So this is the hundredths place. Look to the number to the right of the hundredths place. And 4 falls in the category of 4 or below, so that means we round down. So that means that the blue number stays the way it is. It doesn't go anywhere. And all the other numbers go to 0. All right, so now it's your turn. Try number 7, and when you come back, we'll do it together. All right, we're back. Whoops, I just remembered I didn't even show you the column there, so I guess we'll have to do it again. Now you have I might forget to do that a couple times this class, show you the column. So we got it round to the nearest 1,000 place if you didn't figure that out already. So go ahead and try this problem, and when you come back, we'll do it together. All right, we're back. So the thousandths place is here. Look to the number to the right. It tells us to round up. So we make the blue number go to 6, and all the other numbers go to 0. So if you got 6,000, good job. Again, I'm sorry I didn't show you the column there. I'm going to forget to do that multiple times in this class, just based on the way that these problem sets are structured. All right, why don't you try number 8, and when you come back, we'll do it together. All right, we're back. The nearest tens place is here. The number next to it tells us to round down, because that falls in the category of 4 below. The yellow number falls in the category of 4 or below, so we round down, so we keep the blue number, and then the yellow number becomes 0. So if you got 110, good job. All right, try number 9, and when you come back, we'll do it together. All right, we're back. The hundredths place is here. The number next to the hundredths place is here, so 6 tells us to round up. So we make the blue number 1 greater, so it becomes 1 greater than 0 is 1, and all the other numbers become 0. So if you got 50,100, good job. Why don't you try number 10, and when you come back, we'll do it together. All right, we're back. The thousandths place is here. Look to the number to the right of the thousandths place, and the 7 tells us to round up. And 7 falls in the category of 5 or above, so we make the 6, the blue number, go up 1. And all the other numbers become 0. So if you got 47,000, good job. Try number 11, and when you come back, we'll do it together. All right, we're back. The tens place is here. The number next to the tens place is here, so the yellow number tells us to round down. So we keep the blue number. We don't change the blue number at all, but the other number becomes 0. So if you got 9,810, good job. Try number 12, and when you come back, we'll do it together. All right, so the hundredths place is here. The number next to the hundredths place is here, so the 5 falls in the category of 5 or above. So we're going to round up. That means the blue number goes up by 1, and the other numbers go to 0. And there you go. By the way, in Europe and probably other areas of the world, they have a more sophisticated way to round when you have a 5 as the yellow number. But in the United States, we have a really simple way of doing it. Just if a number falls in the category of 5 or above, you round up. 4 or below, you round down. But just be aware that in other countries, you might have a more sophisticated way of deciding which number to, or which operation to perform. All right, so now we're going to try something slightly different. These are numbers where when you round, nothing is going to change. Now we're going to round to the nearest 10,000. So let's find the 10,000ths place. We got the ones, the tens, the hundreds, the thousands, and the 10,000ths place. So that's the 10,000ths place. And we look to the number to the right, directly to the right, and that tells us to round down. So the number in the blue, that stays 0, and all the other numbers become 0. But as you can see, all these other numbers already were zeros, so the number actually doesn't change. So this is an example where when you round, the number doesn't change. So instead of writing an approximately equal sign, we might as well just write an exactly equal sign. So the answer to that one was just the same number, 2 million. All right, you're going to find the same type of thing for number 14. We'll do 14 together, and you can try 15 and 16. We're going to round to the nearest 100. This is the hundredths place. We look to the number to the right, and the 0 obviously tells us to round down. So the number in blue stays the way it is. And the yellow number and all numbers to the right of the yellow, they go to 0. But again, as you can see, they already are 0. So we just have the same number, and we can erase the approximately equal to sign and just write an equal to sign. So these are examples of numbers where when you round them, they don't change. Why don't you try number 15, and when you come back, we'll do it together. All right, we're back. Here's the thousandths place. Actually, here's the thousandths place. Look to the number to the right, and it tells us to round down because 0 falls in the category of 4 or below. So what that means is that the blue number does not change, and the yellow number and all numbers to the right of the yellow, they go to 0, but they're already 0, so the number doesn't change, and we just write an equal sign instead of approximately equal to. So if you got 7,000, good job. Let's try one more of those. Number 16. When you come back, we'll do it together. All right, we're back. We need to find the 10,000ths place. This is the 10,000ths place. We look to the number directly to the right, and that tells us to round down. So what we mean when we say it rounds down is the blue number does not change, and the yellow number and all the other numbers go to 0, but they're already 0, so we can just write an equal sign instead of an approximately equal to sign. So if you got the same number, you're getting the idea. Alright, so now let's go to something a little different. We're going to round 86 to the nearest hundred. So 8 is, well, the hundredths place is actually here. But as you can see, there's nothing there. So we look to the number. You can just consider the blue highlight to be 0. Just consider that number to be 0 there. So we look to the number to the right, and obviously 8 falls in the category of 5 or above, so we round up. So if this number is considered to be 0, then we just round it up to 1, and the yellow number and all numbers to the right of the yellow number, they go to 0. So that problem was a little different because we had a number that was non-existent, a number here, so we just considered it to be 0, and we raise it up to 1. All right, let's try another one of those. Now we're going to round to the nearest 1,000. This is the thousandths place. As you can see, there's nothing there, but we look to the number to the right, and that tells us to round down. So that means the blue number stays the same. Now there is no blue number, but it's considered to be 0. So that stays the same, and the other numbers become 0 too. The yellow number and all the numbers to the right of the yellow, they become 0. But there is really no such thing as 0, 0, 0, 0. Why would we write 4 zeros when we can just write 1 0? So if you round to the nearest thousand in that problem, and you're starting off at 340, then it just rounds to 0. If you round to the nearest ones place, then it would just be 340. If you round to the nearest tens place, it would be 340 again. And if you round to the nearest hundreds place, it would be 300. But if you round to the nearest thousands place, it would just be 0. So it just depends on how accurate you want to be with these numbers. All right, so why don't you try number 19? And again, be careful because we're rounding to the nearest 10,000ths place, not thousand, 10,000ths place. So try 19, and when you're done, we'll come back and do it together. All right, we're back. This is the 10,000ths place. 5 tells us to round up. So we can just consider the blue number to be 0, so it rounds up to 1, and all the other numbers, the yellow number and all numbers to the right of the yellow number, they become zeros. So if you got 10,000, good job. And make sure you're writing approximately equal to, not equal to, because they're not, 5,500 is definitely not exactly equal to 10,000. All right, try number 20, and when you come back, we'll do it together. All right, we're rounding to the nearest 100. This is the hundredths place. The 4 tells us to round down. That means we keep the blue number the way it is, which is 0, and those other numbers become 0. So we have 0, 0, 0, but 0, 0, 0 isn't a number. We just write 0, because why would we write 3 zeros when we can just write 1? So if you got 0 for number 20, good job. All right, try number 21, and when you come back, we'll do it together. All right, we're back. This is the thousandths place. The 6 tells us to round up. So the blue number is considered to be 0. So if we round up 1, it would be just 1. And all the other numbers would go to 0. So you have 1,000. If you got 1,000, good job. All right. Now number 22, something different's gonna happen here. It says round to the nearest hundredths place, or nearest hundred. So this is the hundredths place. So we look to the 8. The 8 tells us whether or not to round up or down. So 8 tells us to round up. But there's something different that's going to happen here. We're going to make the 9 in blue go up by 1. But the problem is it's the highest one-digit number possible. So how can you go up by 1? There's nothing to go up to. So what you do is you make this number go up by 1. So the 6 goes up to 7, and all the other numbers become 1,000, or become 0. And there you go. No big deal. So we'll try another one of those. We'll try a couple, just so you have it down. Rounding to the nearest thousandths place. So 1,000 is here. The 5 tells us to round up, but the 9 can't go up to another one-digit number, so we make the 4 go up. So the 4 goes up to 5, and all the other numbers become 0. Again, this is the special case when the number that you're the place value of the number that you're rounding up to, or to the nearest number, is the blue number is 9. That's a special case when that blue number is 9. Now rounding to the nearest 10. This is the tens place. The 6 tells us to round up, but we can't make the blue number go up another one digit, so we make this number go up by 1. So the 1 goes to 2, and all the other numbers, as usual, go to 0. So 196 rounded up to 200. So you're going to be asked to round to certain degrees of precision, and these instructions tell you how close the person wants the number to be. That's the whole point of this class, is to learn how to round numbers. All right, rounding to the nearest 100. This is the 100 place. You can see it's a 9. The 6 tells us to round up, but we can't round the blue number up to another one digit, so we round the 7 up to 8. Whoops. And all the other numbers become 0. So again, this is a special case. So why don't you try number 26, and when you come back, we'll do it together. We're rounding to the nearest 1,000. All right, we're back. So this is the thousandths place. The 7 tells us to round up, and we have to make the purple number go up by 1 because the blue number is 9. The special case when the blue number is 9. So we have 30,000. If you got 30,000, good job. All these numbers become 0, and in the special case, this number becomes 0 also, and this number goes up by 1. So we already learned how to round. We already learned the basic concept of rounding. But this is just a special case. Rounding to the nearest tens place, number 27. Why don't you try that? And when you come back, we'll do it together. All right, 9 is a tens place. The 9 here tells us to round up, but the 9 in the blue can't go up to another one digit. So we make the number to the left of the blue number go up by 1. So 499 rounds to 500. So if you got 500, good job. All right, number 28. Round to the nearest 100. When you come back, we'll do that one together. Go ahead and try it yourself. All right, this is the hundredths place. Again, you have the special case where you have a 9. The 5 tells us to round up, but we have to round this number up 1 because the 9 can't go up to another one-digit number. So it becomes 101 6,954. Wait, I'm sorry. Not thinking about what I'm doing. Those would just be zeros. So if you got 101,000, good job. All right, try 29, and when you come back, we'll do it together. All right, we're rounding to the nearest thousand. This is the thousandths place. The 6 tells us to round up. We can't go up to another one digit when the blue, so we make the purple number go up by 1. So it becomes 80,000. So if you got 80,000, good job. Try number 30, and when you come back, we'll do it together. All right, we're back. Rounding to the nearest 10. The 6 tells us to round up. So we have to make this number go up 1 because the blue number can't go up to another one digit. So we have 62,300. So if you got 62,300, good job. So again, those are just special cases of rounding when you have a 9 for the blue number. All right, number 31. Same situation. Actually, let's see here. You know what? Let's skip 31 and 32 because those are pretty much the same problem. I don't think we need to do that. This problem is a little bit different. This is kind of what we were doing before. So let's do this one together. We're going to round to the nearest 10. This is the 10 place. So we look to the 5. The 5 tells us to round up, right? But the 9 can't go up another one-digit number, so we have to make this number go up by 1, but there is no number there. If there's no number there, we just assume the purple to be 0. So if it goes up by 1, 0 goes up by 1, it just becomes 1, and the other numbers go to 0. So that was a special case. That's why I put the red dot there, a special case. So 34 is another special case problem. Rounding to the nearest 100. Sorry, I'm throwing the screen around there. This is the 100 place. The 7 tells us to round up. But the blue number is 9, so we have to round this number up. That number is considered to be 0, so if we round it up by 1, the 0 becomes 1, and all the other numbers become 0. So again, this is just a special case of the 9 in the blue highlighter, the blue place. Why don't you try 35? When we come back, we'll do it together. All right, we're back. This is the thousandths place. The 6 tells us to round up, but the 9, the blue number is 9, so we have to make this number go up by 1 in the purple. So it becomes 10,000. So if you got 10,000, good job. Try number 36, and when you come back, we'll do it together. All right, we're back. 10's place. 9 tells us to round up, but we can't make the blue number go up anymore, so we have to make the purple number go up. So the purple number is considered to be 0, so it goes up by 1, so it becomes 100. So if you got 100, good job. All right, so now we're going to go to that special case. Another problem with the special case where we have 9 is the blue number. We're going to round to the nearest 100. This is the 100 place. The 6 tells us to round up, right? But because we have a 9 in the blue place, we can't round it up to a one-digit number, so we have to make this number round up to a one-digit number. The problem is the number in purple, that can't go up by a one-digit number either, so we have to make this number go up by 1. You see how that works? So the 4 goes up to a 5, and all the other numbers become 0. So if you just have a long string of 9s, you just keep going all the way to the left until you get to a number that's not 9. So again, this is just a special case of rounding. So why don't you try, actually let's do this one together. Nearest thousand. This is the thousandths place. 7 tells us to round up. We're going to round this number up, but that number is also 9. So we have to round this number up 1. So the number becomes 6,900,000. So this is just a special case where you have a 9 in the blue, 9 in the blue, and you also have a 9 in the purple. All right, so see if you can do number 39, and when you come back, we'll do it together. All right, we're back. 9 is in the tens place. So we look to the 5, it tells us to round up. But there's another 9 in the purple, so we have to round up. We have to move over to the next number, and the 7 rounds up to an 8. And so that number rounds to 8,000. So if you got 8,000, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. Now we're rounding to the nearest hundred. Why don't you try that problem, and when you come back, we'll do it together. All right, we're back. This is the hundredths place. 6 tells us to round up. So we round, but there's a 9 in the purple place also. So we have to round the red number up 1. So it rounds to 310,000. So if you got 310,000, good job. Why don't you try 41, and when you come back, we'll do it together. All right, we're back. This 9 is in the thousandths place. The 9 next to it tells us to round up. So we have to round this number up, but it can't go up anymore. So we have to change this number. So the 1 goes up to 2, and all the other numbers go to 0. So if you got 200,000, good job. Try number 42, and when you come back, we'll do it together. All right, we're back. This is the tens place. 7 tells us to round up. So, but this number is also 9, so we have to round this number up 1, and all the other numbers become 0. So we have 81,000. If you got 81,000, good job. All right. Now, we're just going to add some more 9s here. So we're going to round, for 43, we're going to round to the nearest 100. So this is the hundredths place. The 6 tells us to round up. So we're going to round the purple number up 1, but the problem is it's 9, so we have to round the next number up by 1. But the problem is it's 9 also, so it can't really go up anymore. So we're going to have to get a new highlighter color, maybe green. And we're going to have to round this number up by 1. So that becomes 2 million, and the green goes up by 1 to 4, and all the other numbers go to 0. So 2,400,000. So as you can see, this is just another special case of rounding. All right, 44. Rounding to the nearest 1,000. Thousandths place. Round up. But that's a 9 also. And that's 9 also. So we have to make this number, which is non-existent, we have to make that go up by 1. So the green is just considered to be 0, so it goes up to 1, and all the other numbers become 0. So that's 1,000,000. So 999,748 becomes 1,000,000. We round it up to 1,000,000. All right, 45. So let's see if you can, again, the difference between these numbers is you have 3 9s as opposed to 2 9s that we did in the last problems here, and 1 9 in the problems up here. At least 1 9 in that critical position. So try 45, and when you come back, we'll do it together. All right, we're back. The tens place is here. 5 tells us to round up. There's another 9 though, so we have to go over to the next number, and there's another 9, so we have to go over to the next number, and finally the green number rounds up to 7, so it becomes 70,000. So if you got 70,000, good job. All right, try 46, and when you come back, we'll do it together. All right, we're back. Here's the hundredths place. 7 tells us to round up, but we have a 9 there, and we have a 9 there, so we have to finally round up the 4, and you're left with 400,000, or excuse me, 500,000. So if you got 500,000, good job. If you didn't, that's okay. Just figure out what you did wrong. All right, number 47, try that one, and when you come back, we'll do it together. All right, we're back. We're rounding to the nearest thousandths place. The 8 tells us to round up, so we round up to, we round this number up, but it's already up. So we got to round this number up, but it's already up. So we got to round this number, so the 5 becomes a 6, and you're left with 56 million. So see how much more simple these numbers are? They're so much simpler than these numbers here. They're so much simpler than the blue. All right, why don't you try 48, and when you come back, we'll do it together. All right, we're back. We're rounding to the tens place. The blue is the tens place. The 9 tells us to round up. But you can see we have a 9 there, and we have a 9 there. So we have to take this number, which is really nothing. We consider it to be 0, and we have to round it up to 1. So it becomes 10,000. If you got 10,000, good job. All right, so now we're just adding more 9s. And I know I'm spending a lot of time on this special case where you have a 9 in the blue position. But I just want to make sure you got this. So we're going to round to the nearest 100. This is the 100th place. The 6 tells us to round up. But there's a 9 in the other position, so we have to move over. There's another 9, so we have to move over again. And there's another 9, so we have to move over again. And there's another 9, so we have to move over again. And there's another 9, so we have to move over again. Let me adjust this real quick. Adjust my colors here. So there's another 9 we have to move over again. And so finally the 5 let me get some more highlighter colors here. Try some orange. The 5 finally goes up to 6. So I think you got the point here. I don't really need to keep explaining the same principle. I need to go down the thickness there. So that'll be 600 million. I think you've got the point, but just to be sure, let's do some more problems here. Now to the nearest 1,000. Why don't you try number 50, and when you come back, we'll do it together. So as long as you have 9s, you just keep going as farther and farther to the left. When you come back, we'll do it together. All right, we're back. This is the thousandths place. The 5 tells us to round up, but we just have to keep going because we round to here, and then that bumps this number up, and it bumps this number up, and it bumps this number up, and it bumps this number up, and finally you get to the 7. The 7 goes up to 8. So we have 8 trillion. That's 9 zeros. So if you got 8 trillion, good job. And I know we haven't done trillions yet, but that's okay. You don't have to say the number. Try number 51, and when you come back, we'll do it together. All right, so this is the tens place. The 8 tells us to round up. So we just keep rounding up and up and up and up and up and up until we get to the 6, because it's the special case where you have a bunch of 9s to the left of the blue number. And we end up with 7 million. So if you got 7 million, good job. All right, number 52. Now we're doing something much different. Do you see something different here? What's different is we have a decimal, and we have numbers to the right of the decimal. In the previous problems, we didn't have a decimal on the number to the right of the decimal. Well, technically the decimal is always there, but we just can't see it. It's invisible. But now we have not only a decimal, but we have numbers to the right of the decimal. So the rules are pretty much the same, but there's going to be a slight difference. Let me show you what I mean. So we're going to round to the nearest thousandths place. So this is the thousandths place. We look to the number to the right, and that tells us to round up because it's in the category of 5 or above. So we round up. So the blue number is going to go up by 1, as usual. That becomes 9. And all the other numbers become 0. And the 4 and the 3, they become 0 also. So as you can see, it's the exact same problem. No difference whatsoever. Except these zeros, if you recall from the previous classes, these zeros, we don't really need to write those. The zeros to the right of the decimal are ending zeros. If there were a number here, for example 8, then you would have to write this 0. But since we just have a bunch of zeros to the right of the decimal, you can just make those disappear. So we just say that this number rounds up to 9,000. So that's the only difference. You can see it's pretty much the same operation. We're just making the zeros to the right of the decimal disappear. Because 9,000.00, all that means is 9,000 plus 0 out of 100. But 0 out of 100, if you recall, if you cut a pizza into 100 parts and you eat all of it, so there's nothing left, it's obviously just 0. So we just leave it as we just take those zeros and make them disappear. All right. If you don't understand that explanation, that's okay. You don't need to understand it right now. You just need to understand the operation. This is not stuff that most mathematicians think about. They just do it. They're just trained to do it, and they just do it without thinking about it. All right, so now we're going to round to the nearest 10. This is the tens place. Now the 2, we haven't rounded down in a while. The 2 now tells us to round down because it falls in the category of 4 or below. So that means that we're going to keep the number in blue the way it is. And of course, all these numbers are going to stay the same. So 23, we're going to keep the number in blue, so the 3 stays. And then all the other numbers go to 0. I'm sorry, I'm having trouble fitting here. So 23,430, and all the other numbers go to 0. So the yellow number told us to round down, so that means we keep the blue number the way it is. We don't raise it. We just keep it as a 3. and then all the other numbers, the yellow number and all the numbers to the right, they go to 0. But like I said before, the numbers to the right of the decimal, we can just make those disappear. And we have 23,430. All right, so why don't you try the next problem, and when you come back, we'll do it together. All right, we're back. So rounding to the nearest hundred, this is the hundredths place. The 8 tells us to round up. So we round the 4 goes up to a 5, and all the other numbers become 0. But again, these zeros you don't need to write because they're to the right of the decimal, so you can just write 77,500. I guess you can just keep this number to show your work. All right. So if you didn't understand those problems, that's okay. We're going to do some more here. Try number 55, and when you come back, we'll do it together. All right, now we're going to round to the nearest thousandths place. This is the thousandths place. Look to the number to the right, and the yellow number tells us to round down. So that means the blue number stays the same, and the yellow number and all numbers to the right of the yellow, they go to 0. So make sure that looks like a comma or a decimal. But again, the zeros to the right of the decimal we can just get rid of because they're ending zeros and they're to the right of the decimal, so your answer should be 642,000. All right, why don't you try number 56, and when you come back, we'll do it together. All right, we're back. We're going to round to the nearest 10, tens place. That's here. The 6 tells us to round up, so the blue number goes up by 1, and all the other numbers to the right of the yellow and also the yellow, they go to 0. But you don't have to write the ending zeros to the right of the decimal. So if you got 110, good job. Try number 57, and when you come back, we'll do it together. All right, we're back. Here's the hundredths place. The yellow number tells us to round down, so that means the blue number stays the same, and the yellow number and all numbers to the right of the yellow number, they go to 0. But we don't need to write the ending zeros to the right of the decimal, so we can just write 500. If you got 500, good job. Why don't you try number 58, and when you're done, we'll do it together. All right, we're back, rounding to the nearest thousandths place. So that's the thousandths place. Look to the number to the right, and that tells us to round down. If we round down, that means the blue number stays the same, and the yellow number and all numbers to the right of the yellow number become 0. But we don't need to write the zeros to the right of the decimal because they're not only to the right of the decimal, but they're also ending zeros. So we just write 77,000. And by the way, what I mean by ending zero, again, is if you had 77,000.01, this 0 you cannot get rid of even though it's to the right of the decimal because it's not an ending 0. And if you have something called a captive 0, for example, 77,000.101 or 103 or whatever, the 0 is captive. The 1 and the 3 are surrounding the 0, so it's called a captive. It's held captive by the 1 and the 3, so you cannot get rid of this 0 or the 0 between the 1 and the 3. Those are not ending zeros. Even though they're to the right of the decimal, they're not ending zeros, so you can't get rid of them. But these zeros, they're not only to the right of the decimal, but they're ending zeros. so you can just get rid of those. Why don't you try number 59, and when you're done, we'll do it together. All right, we're back. We're going to round to the nearest 10. This is the tens place. The 5 tells us to round up. That means the blue number goes up 1. And the yellow number and all numbers to the right of the yellow number go to 0. But again, we can just leave off the 0 to the right of the decimal because it's not only to the right of the decimal, but it's an ending 0. So if you got 1,840, good job. Try number 60, and when you come back, we'll do it together. All right, we're back. Here's the hundredths place. The 9 tells us to round up. So if we're going to round up, that means the blue number goes up by 1, and the yellow number and all numbers to the right of the yellow number go to 0. But again, we can leave off those ending zeros, but only if they're ending and to the right of the decimal. So if you got 74,300, good job. Try let's do number 61 together. We're going to round to the nearest 1,000. That's here. The 6 tells us to round up. So that means the blue number is going to go up by 1, so it's 0. So to go up by 1 from 0, they just become 1. And the yellow number and all other numbers to the right of the yellow number become 0, as usual. And as usual, you can leave off the ending zeros to the right of the decimal. So if you got 61,000, good job. Try 62. Oh, actually, I'm sorry, we did that one together. Try 62, and when you come back, we'll do it together. All right, we're back. We're rounding to the nearest 10. This is the tens place. The number next to it tells us to round down. So that means the blue number does not change, and the yellow number and all numbers to the right of the yellow number go to 0. But as usual, you can just leave off those ending zeros to the right of the decimal. So if you got 8,000, good job. Try 63, and when you come back, we'll do it together. All right, we're back. Here's the hundredths place. The 0 tells us to round down, so that means the blue number does not change, and the yellow number and all numbers to the right of the yellow number, they just go to 0. And you can leave off those ending zeros, so if you got 500, good job. And by the way, this number is correct. It's not wrong. It's just we don't need those ending zeros. If you write those ending zeros, people are going to wonder why you did that. All right, now we're going to round to the nearest tenth. The difference here is that in all the previous problems, we rounded numbers. The place that we rounded to, all the numbers were to the left of the decimal. So now we're rounding to tenth, th. So that means it's not 10 over here. That means it's 10 here. And again, it starts at 1 here, ones place, tens place, hundreds place. But to the right of the decimal, it doesn't start at 1. It starts at tenths, hundredth, tenth, hundredth, thousandth, so forth. So we're going to round to the nearest tenth place, and it's pretty much no difference. The number to the right tells us whether or not to round up or down. The 8 tells us to round up. So that means the 3 is going to become 4, and all the other numbers are going to become 0. But as I said before, because these are ending zeros to the right of the decimal, they have to be to the right of the decimal. The zeros have to be to the right of the decimal, and they have to be ending zeros. If you had something like 404 here, 47.404, you could not get rid of this 0 because that's what they call a captive 0. You can't get rid of that. If you have 47.004, those are also captive zeros. so we can't get rid of those. But if you have ending zeros here, then you can get rid of those. I know that's kind of confusing, but that's just the way it is. Just get used to it. So we have 47.4. All right, 65. Now there's something new we have to talk about here. We're now going to round to the nearest ones place. This is the ones place, if you recall, if you're looking at your chart. But I just want you to understand very clearly, it's called the nearest ones place, but it's also called the unit place, or the nearest unit value. So there's a lot of different ways to say it. You can say it round to the nearest whole number, which we're going to talk about later on. If you hear the nearest whole number, it's this number. If you hear the nearest ones place, it's this number. And if you hear the nearest units place, it's this number also. So units, ones place, units place, ones place, or nearest whole number, that all means the number directly to the left of the decimal. That's a special place right there, because those are whole number, one-digit whole numbers. All right, so this is the special number. 5 tells us to round up. So we're going to round the blue number up. To 2, and all the other numbers become 0. But again, you don't have to write the zeros to the right of the decimal. All right, let's see here. We're doing good, 66. Now we're going to round to the nearest hundredth. So again, we start at 10th. We don't start at 1, we start at 10th. So hundredth, this is the 10th, and this is going to be the hundredth. Look to the number to the right, that tells us to round up. So the blue number is going to go up by 1. And all the other numbers are going to go to 0. But we don't need those zeros to the right, because those are ending zeros to the right of the decimal. All right, so hopefully you've got the idea. Let's do one more together, and you can do some of these on your own. So we're going to round to the nearest 10th. This is the 10th place. The 5 tells us to round up. So the blue number goes up 1, and all the other numbers go to 0. But since those numbers are to the right of the decimal and they're ending zeros, we can just make them disappear. And again, just to explain why that is, you have 0.400, which is the same thing as 400,000, or 400 thousandths. We explained that in a previous course, but in a previous class. But 400 thousandths, that just reduces to 4 over 10, which is the same thing as 0.4. So 0.4 is the same thing as 0.400. Now, if you're confused by that, just forget it. Just remember that ending zeros can disappear when they're to the right of the decimal. But captive zeros, they cannot disappear. So if you have 0.404, that 0 does not disappear. Or if you have 0.004, for example, these zeros do not disappear because those zeros are captive. They're not ending zeros. And the reason we call them captive, by the way, is because they're held captive. They're in between these two 4s. The zeros in between those two 4s. That's why they're called captive zeros. All right, so now it's time for you to try. Try number 68. And again, just to let you know, the units place, the ones place, that's here. So round to the nearest ones place on 68, and when you come back, we'll do it together. All right, we're back. So the 6 tells us to round up. The blue number goes up by 1, and all the other numbers go to 0. But those other zeros can disappear because they're to the right of the decimal. So if you got 57, good job. All right, 69, attempt that problem, and when you're done, we'll come back and do it together. All right, the hundredth place is here. The 0 tells us to round down, so we keep the blue number the way it is. We don't change the blue number at all. But the other numbers become 0, the numbers to the right. And of course, you can just make those disappear because they're to the right of the decimal and they're ending 0. So if you got 136.83, good job. All right, to the nearest 10th place. Try 70, and when you come back, we'll do it together. All right, we're back. This is the 10th place. The 6 tells us to round up. So this is actually a special situation because the blue number is 9. You see that? The blue number is 9. So that means we have to round this number up because the 9 can't go up anymore. So it becomes 88.000, which is the same thing as 88. So if you got number 70 correct, you were especially good on that one, because that was a special problem where the blue number ended up being 9. All right, so now we'll try 71. When you go and attempt that one, and when you come back, we'll do it together. All right, we're back. Here's the ones place. The 6 tells us to round up, so we're going to round this 9 up, but it's already a 9, so we have to go to the next number. And so the 3 is going to go up to a 4, and all the other numbers, as usual, are going to go to 0. And we can just drop those zeros to the right of the decimal, because they're ending zeros. So if you got 400, good job. Try number 72, and when you come back, we'll do it together. All right, we're back. Here's the 100th place. The 8 tells us to round up. But as you can see, we just got a bunch of 9s here, so we're going to have to keep going over until we get to the 7, and finally the 7 we're going to round up. So the 7 is going to become 8, and all the other numbers are going to become 0, as usual. But we don't have to write these zeros to the right of the decimal because they're ending 0. So if you got 800, good job. So this problem is pretty much the same situation here. Yeah, it's really no different. So why don't you try number 73, and when you come back, we'll do it together. All right, we're back. This is the 10,000th place. Again, it's 10th, 100th, thousandths, 10,000ths, 100,000ths, and so on and so forth. You just take this place number, 10th, and you multiply it by 10. 10 times 10 is 100. And then take 100, the hundredths place, and multiply that by 10, and you get 1,000. So thousandths place, and so on and so forth. All right, so this is the 10,000th place. The 6 tells us to round up, but we got a bunch of 9s, so we just have to keep going all the way till we get to the 3. And the 3 rounds up to 4, and all the other numbers become 0. But we don't have to write those other numbers because they're ending zeros to the right of the decimal. Why don't you try number 74, and when you come back, we'll do it together. All right, thousandths place. 7 tells us to round up, but there's a bunch of 9s, so we have to just keep going all the way till we get to that 0, and finally round up the 0 to 1, and all the other numbers become 0. And we could just leave those zeros off. Why don't you try 75, and when you come back, we'll do it together. All right, rounding to the nearest 100,000ths. That's here. The 9 next to it tells us to round up, but we have to just keep going all the way till we get to the 9, because all those other numbers to the left of that blue number are also 9s. So the 8 is going to round up to a 9. And we have 1, 2, 3, 4, 5, 6, 7, 8 zeros, but again, we don't really need those zeros. We can just say 9. So hopefully you're getting the hang of this. Now remember, I said we're rounding to the nearest, in this problem we rounded to the nearest 1, but it's also called the units value. And the third name for it is, the third way to express that place is the nearest whole number. It's all the same thing. So this would be the nearest ones place, or the nearest units value, units place, whatever you want to call it. But we can also say round to the nearest whole number, and that means round to the nearest ones place. So that's the ones place. The 1 tells us to round down. And so we keep the blue number the way it is, and all the other numbers to the right become 0. So that would just be 82. So these problems are really no different. The only difference is that we're saying round to the nearest whole number. It's just a different way to say round to the nearest ones place. All right, so 82.153 rounds to 82. So why don't you try number 77? When you come back, we'll do it together. All right, we're back. That's the ones place. The 6 tells us to round up. So the blue number rounds up 1, and the other number becomes 0. So no real difference here. Try number 78. When you come back, we'll do it together. All right, we're back. This is the nearest whole number. That's the ones place. 7 tells us to round up. So that rounds up to 7.0000, which you can just write as 7. So if you got 7, good job. All right, now we're going to round to the nearest ones place. The ones place is here. So the 7 tells us to round up. So that means the 0 goes up to 1, and the other numbers go to 0. But we can just write 1. So these problems are pretty much the same thing too. Why don't you try number 80, and when you come back, we'll do it together. This is the unit value, as we said. It's just another way of writing another name for the ones place. The 3 tells us to round down. So the 0, the blue 0, doesn't change, and all the other numbers become 0. But that's just the same thing as saying 0. So number 80 was 0. So maybe we should have done that one together. If you got 0, good job. So you see, we have nearest ones place, we have unit place, and we have nearest whole number. They all mean the same thing. They mean the number directly to the left of the decimal. Sorry, I blacked that out there. To the nearest whole number, so that's here. So attempt number 81, and when you come back, we'll do it together. All right, we're back. So the 9 tells us to round up. So the 0 becomes 1, and all the other numbers become 0. And the zeros you can get rid of because they're ending zeros to the right of the decimal. All right. Try number 82, and when you come back, we'll do it together. All right, we're back. This is the ones place. The 1 tells us to round down, so the blue number doesn't change, and the other number becomes 0, but 0.0 is the same thing as 0, so that number rounds to 0. If you got 0, good job. Try number 83, and when you come back, we'll do it together. All right, we're back. This is the units place. Same thing as the ones place. The 5 tells us to round up, so the 0 rounds up to 1, and all the other numbers become 0. But we can just write that as 1, because the 0 is to the right of the decimal. They're to the right of the decimal for one thing, but they're also ending zeros. So we just make them disappear. Try number 84, and when you come back, we'll do it together. All right, we're back. Whoops. Hopefully you saw it was the nearest whole number. So here's the whole number. 0 tells us to round down. So the 0 doesn't change, and the other numbers become 0, but 0.00 is just the same thing as 0. So if you got 0, good job. All right. On to 85. We're now going to round to the nearest tenth. This is the 10th place. We look to the number to the right, and we can see that there's nothing there, so we can just consider the yellow number to be 0. So the yellow number tells us to round down. So that means, as usual, we keep the blue number the way it is, and all the numbers, the yellow number and all the numbers to the right, they become 0, but they're not even there, so we can just leave it as 46.7. So as you can see, the number didn't change. But if the number doesn't change, that means we can take this approximately equal to sign, we can make it exactly equal to, two straight lines. Let's try number 86. The 100th place is here. We have the same situation. This number, yellow number, is considered to be 0, which means we just keep the blue number the way it is. And the yellow number and all numbers to the right go to 0, but there are no numbers there, so the number just stays the same, which means that we can get rid of the approximately equal to sign and write just equal to. Why don't you try 87, and when you come back, we'll do it together. All right, we're back. The thousandth place is here. The number next to it tells us to round down because the yellow number is just considered to be 0 because there is no number there. So if we're rounding down, the blue number stays the same and the yellow number and all numbers to the right go to 0, but there are no yellow numbers or any numbers to the right of the yellow, so it just stays the same. And we can just change that approximately equal to sign to equal to. So these are just examples where when you round, the number doesn't change, it just stays the same. All right, now we're going to round to the nearest thousandth place. This problem might be slightly different because there's a dot there. But why don't you try this problem on your own and see if you can figure out what's going to happen. When you come back, we'll do it together. All right, we're back. So this is the 1000th place. That's the farthest over we've gone, I believe, far to the right of the decimal. And this number tells us to round down. So we keep the blue number the way it is, so we keep that as a 0. And the yellow and all the numbers to the right of the yellow, they go to 0. And of course, there are no numbers to the right of the yellow number. So we just end up with 0.8000. So we could just leave our answer like that, but the difference of this problem is, again, I've said it before, if you have zeros to the right of the decimal, which are all these, to the right of the decimal, here's the decimal and they're to the right of the decimal, and the zeros are also ending zeros, which means they're not captive, they're not between numbers. Like if you had 0.8005, these are between two numbers, 8 and 5. Then you can't get rid of those zeros because they serve as placeholders. But in this case, when you have ending zeros, they're not between two numbers, then you can actually just get rid of those. So we end up with 0.8. Now, writing 0.8000, that's not incorrect. That's correct. But engineers and scientists are going to laugh at you because they know you can just write it as 0.8. Why in the world would you write it as 0.8000 when you can just write it as 0.8? And again, the reason for that, if you go back to the previous class, 0.8000 is the same thing as 8,000 10,000ths. But that fraction just reduces to 8 over 10, which is what this what 0.8 means. So in case you're wondering why this expression is equal to this expression, that's the reason. And again, if you didn't understand that, don't worry about it. Mathematicians and scientists and engineers, they don't even think about it. They just gain fluency and then they don't think about it. All right, so that was kind of a special problem. If you got 0.8, good job. Now we're going to round to the nearest hundredth. This is the hundredth place here. The 4 tells us to round down. So what that means is we keep the blue number, the 0, and the yellow number and all numbers to the right of the yellow number, they change to 0. But because these zeros are to the right of the decimal and they're also ending zeros, we can just get rid of those. So our answer is 35.6. All right, so I want to demonstrate something. So let's get rid of that real quick. Let's go back to that problem. Let's try rounding off to the nearest thousandth place, because something special is going to happen. We'll put that answer back the way it was in a second. Let's just pretend that we're rounding off to the nearest thousandth place. Instead of the hundredth place, let's round off to the nearest thousandth place. I just want to demonstrate something quickly here. So the 9 tells us to round up. So that tells us that the blue number goes up by 1, up to 5, and the yellow number and all numbers to the right of the yellow number go to 0. Now here's what I want to demonstrate. I've been talking about zeros to the right of the decimal that are also ending zeros. In this problem, we have something special because we have an ending 0 to the right of the decimal, and we also have a captive 0 to the right of the decimal. It's extremely important to understand the ending 0, that can just disappear. It's not wrong to write it. You can leave it like this. That would be fine. But there's just no reason to put that ending 0. So you can get rid of that one, but you cannot get rid of the captive 0. And again, the reason it's called captive is because there's a 5 and the 6 on either side of the 0. That's called captive. The 6 and the 5 are holding the 0 captive. But the ending 0, so you can't get rid of the captive 0, but the ending 0 you can get rid of. So I just wanted to demonstrate that. All right, now we're going to round to the nearest 10,000th. This is another special problem. So why don't you try number 90, and when you come back, we'll do it together. All right, we're back. The 10,000th place. That's here. And the 2 tells us to round down. So that means the blue number doesn't change. And the other number, the yellow number, goes to 0. But of course, those are ending zeros to the right of the decimal, so you can just write 7. So if you got 7, good job. If you didn't, that's okay. These are specialty problems, so they've got some slight twists to them. Try 91, and when you come back, we'll do it together. You know what? I'm going to change this problem slightly. I'm going to change it to 5, 4, something like that. Just to spice it up there. So go ahead and try 91, and when you come back, we'll do it together. All right, we're back. This is the thousandths place. The 4 tells us to round down, so we're going to keep the blue number the way it is. And then other numbers, the yellow number and all the numbers to the right of the yellow number, they become 0. And all those zeros to the right of the decimal, they're ending zeros, so we can just make them disappear. So if you got 23.5, good job. If you didn't, that's okay. These are specialty problems. All right, try number 92, and when you come back, we'll do it together. All right, we're back. This is the hundredths place. The 0 tells us to round down, so that means the blue number doesn't change. And the yellow number and all the numbers to the right of the yellow number, they become 0. But as you can see, those are ending zeros to the right of the decimal, so you can just make them disappear. So if you got 9, good job. Try 93, and when you come back, we'll do it together. All right, we're back. So we need to find the 10,000th place. That's here. This 1 tells us to round down. So that means the blue number doesn't change. And the yellow number becomes 0, and all the numbers to the right of the yellow number. But these are all ending zeros, as you can see, so we can just get rid of those. And we write 0.1. And remember, we keep this 0 just so the decimal doesn't look like a speck of dirt. All right, why don't you, well, let's do 94 together. We're going to round to the nearest thousandth. So, tenths, hundredths, thousandth. This is the thousandth place. The 2 tells us to round down. So the 0 stays the way it is, the blue number stays the way it is, and the yellow number goes to 0, but as you can see, 0.0000 is just the same thing as 0. So that would just be 0. Try number 95, and when you come back, we'll do it together. All right, we're back. This is the hundredth place. The 4 tells us to round down. If we round down, that means the blue number doesn't change, it just stays 0. And the 4 becomes 0. So as you can see, that would just be 0. So if you got 0, good job. Try 96, and when you come back, we'll do it together. All right, we're back. 10,000th place, that's here. The 3 tells us to round down. So that's just going to be 0.00000, which is the same thing as 0. And I'm being a little bit, I'm going a little too far with these problems. I think you got the point. But I just want to be thorough here. So try, let's see, actually 97, 98, and yeah, 97, 98, they're pretty much the same problem. So this is gonna, if you round to the nearest thousandth, this is just gonna end up being 0 again. And why don't you try number 98? All right, we're back. If you got 0 for number 98, it's the same situation. All right, so now we have just a few more problems. We have 1, 2, 3, 4 more problems, and then we'll be done. I'll be done. You're not going to be done because you need to do the homework. You might have to eat lunch first, or dinner, or breakfast, or whatever, and then you can do your homework. But you want to get your homework done as quickly as possible, so you're going to hopefully work on that as soon as possible. But I'm going to be done. The class is going to be done after 4 problems. So we're on to number 99. It says, estimate the following sum by rounding the first number to the nearest 10, that's this number, and the second number to the nearest unit value, that's this number. Then add the numbers in your head. So if you're confused by all that, don't worry, I'm going to explain. All right, so we're going to round this number to the nearest 10. So I'm going to let you do that. So go ahead and do that, and when you're done, we'll come back and do it together. All right, we're back. So this is the 10, tens place. The 9 tells us to round up. So the 8 is going to go up to 9, and all the other numbers are going to become 0. But we can just leave that ending 0 off, and so it just rounds to 90. Long story short, That first number rounds to 90. All right, now it says round the second number to the nearest unit value. So remember unit value? Unit value means the number in the ones place. So we look to the number to the right, and that tells us whether or not to round up or down. So why don't you round this number, and when you come back, we'll do it together. All right, we're back. So the yellow tells us to round up, so we make the blue number go up by 1, and all the other numbers become 0, but we don't have to write those zeros because they're ending zeros. So long story short, this number rounds to 90, and this number rounds to 2. So if we tried to add, and I'm going to add the plus sign there. If we tried to add these two numbers, it might not be so easy to do that because those are you know, there's a lot of numbers there. So what we did is we said, well, we don't need the exact answer, so we'll just round those numbers off to 90 and 2, and then we'll add 90 and 2. So that's going to be so much easier, just 90 plus 2. What is 90 plus 2? Well, if you said 92, you were right. So this is called estimation. We're estimating. So let's see here. Let's do number 100. So it says estimate the following difference. Remember, if it's addition, it's called the result. 92 is called the sum. But if it says difference, difference is the result that we get. So this is subtraction. Estimate the following difference by rounding the first number to the nearest 100. So let's go ahead and do that. Round this number to the nearest 100, and when you come back, we'll do it together. All right, we're back. So this is the hundredths place. And the 9 tells us to round up. So the 7 becomes 8, and all the other numbers become 0. But we can leave that 4 0 off. And it says round the second number to the nearest 10. So why don't you do that? Round this number to the nearest 10, and when you come back, we'll do it together. All right, we're back. So this is the nearest tens place. So the 8 tells us to round up, so we make the 4 go up to 5. And we don't have to write the other, we don't have to write that 0 there. So now it becomes 800 minus 50. So you can probably do that in your head. If you can't do it in your head, then just, you know, line it up vertically, but you really don't need to do that. 800 minus 50 is, what would that be? If you said 750, good job. So we haven't really done a lot of, they call that mental math. Some people call that mental math when you do it in your head. We haven't really done a lot of that, but you need to start getting used to that. If you're a very, very young person, or if you're just a person who hasn't done a lot of calculations, that might not have been easy, but if you line it up, 0 minus 0 is 0. 0 minus 5 you can't do, so you borrow. Give the 1 to the 0, it becomes 10. 10 minus 5 is 5. 7 minus nothing is 7. So that's the way that we learned how to do it. But you need to start getting used to doing some of that stuff in your head. And when I say do the stuff in your head, I don't mean do this in your head. I didn't do that in my head. I just remembered that 800 minus 50, you just subtract 50 and you end up with another 50. These are just things that you're going to learn with the experience. All right, so number 101. And by the way, when you do the homework, and I think there's maybe 5 or 6 problems where you have to do operations, you might have to go back to the previous class to remember how to do addition, subtraction, multiplication, and division. We don't have a lot of time to do more of these problems. I don't want this class to go too long, so I'm only going to give you 4 of these, but hopefully you can refer back to the previous classes if you forget how to do the operations. All right, so estimate the following product. That's the number we get. So this is the sum, this is the difference. The product is what you get after you multiply, so it says estimate the following product by rounding each number to the nearest unit value, then multiply in your head. So we're rounding to the nearest unit value on both these. That means this place and this place, so go ahead and do that for both those numbers. Start by rounding 0.84 to the nearest unit place, and when you come back, we'll do it together. All right, we're back. So that 8 tells us to round up, so we make the blue number go up by 1, and all the other numbers go to 0. But again, you can just leave those zeros off. So we're just going to write it as 1. And now round 1.2 up to the nearest unit value, which is here. And when you come back, we'll do it together. All right, so we're back. The 2 tells us to round down, so the blue number stays the same. Unlike in this situation, the blue number went up by 1. And the other number becomes 0, but again, that's ending 0 to the right of the decimal, so you don't need it. And you just put your multiplication sign. So we rounded 0.84 up to 1, and we rounded 1.2 up to 1. So now 0.84 times 1.2, that's hard. That takes a lot of calculations. But 1 times 1, that's easy. Remember, whenever you multiply a number by 1, it doesn't change the number. You just end up with 1. For example, 8 times 1 is 8. 7 times 1 is 7. Or if you switch it around, 1 times 6 is 6. So on and so forth. So the same is true with 1. If you multiply 1 by 1, it doesn't change it. It just stays 1. All right. So it's important to understand that these are approximations, and I should actually write the approximately equal sign. Actually, I'm not going to do that. That's not really proper notation if you're going down. But I'll just leave that off for now. All right, so we have one more problem. Estimate the quotient, that's the result after you divide, to the right. Estimate the quotient to the right. Estimate the quotient to the right, this here, by rounding the first number to the nearest 10. So let's go ahead and do that. Round that number to the nearest 10, and when you come back, we'll do it together. All right, we're back. This is the 10th place, or excuse me, the tens place, not the 10th place. This is the 10th place. This is the tens place. This number tells us to round up, so the blue number goes up by 1. All the other numbers go to 0, but we can just leave those off. So that number rounds to 40. And it says round the second number to the nearest whole number. So round this number to the nearest whole number. That means this number. So try that. Go ahead and do that. When you come back, we'll do it together. All right, we're back. So the 5 tells us to round up. So the blue number is going to go up by 1. So blue goes up by 1 to 8. All the other numbers go to 0, but we don't have to write the zeros. All right, so we want to do 39.8888. 39.8888 divided by 7.563, but that's going to take a long time. That's a big calculation. But if we round the numbers to 40, because 39.8888 is so close to 40, we can just make it 40. And if we round the 7.563 to 8, yeah, it's fairly close to 8. Now we can easily do 40 divided by 8. 40 divided by 8, well, 8 times 5 is 40, so we know it's going to be 5. And again, it's approximately 5. It's not exactly 5. So 40 divided by 8 is 5 because I know my multiplication facts. I know 8 times 5. 8 goes into 40 5 times, so it's 5. All right. So we don't have time to do a lot of those on your own, more of those operations, but I don't want to make this class go too long because a lot of students taking this class are fairly young students. I don't want to make the class go too long, because they're going to get pretty tired. But that's it for the class. Let's look at the homework before you leave. You can get a screenshot of that if you want, or you can get a screenshot of 2 pages at a time. First 2 pages, second 2 pages. And as you can see, I have all the answers as usual. Be sure to put your name, the date, and the course title, which is Arithmetic. Put the class number and put the title, all the same title. Number all the problems and circle all the numbers. I want you to circle them. No excuses. I don't want you to put a dot next to them. I don't want you to put a rectangle next to them. I want you to circle the numbers. And I want you to write the answers and rectangle the answers. And I want you to check all the answers and make sure that they're correct. If you don't do the problem correctly, you just wasted your time. So let's see here. What else can I remind you of? That's pretty much it. There's 30 problems, but as you can tell, these problems are fairly simple. The only ones that might be difficult is the last 8 problems. You actually have to do operations, but again, you can review from previous classes if you're not sure about those. All right, so that's class number 27. So we have, let's see, I think we have maybe 5 more classes, and then you're gonna be done with this course. So I know what you're thinking. This course is pretty long, and there's a lot of stuff that we learned, and that's correct. But remember, this class is only about 4 months long, and you're in the last 2 or 3 weeks. And once you're done with this class, you're going to cover all of K5 mathematics. That's 6 years of math, all completed with one 4-month course. Or you may be finishing this course in 3 months, or maybe 2 months, depending on how fast you want to go. So I'll look forward to seeing you in the next class. So here we are, signing off.